So please have your calculators out. Today is February 18th. And we are talking about applications of exponential functions today. And it's all calculator work. Again, if you do not have a calculator, you will not be able to do this. You have to have a scientific calculator. So I should see a calculator on everybody's desk. All right. So as the warm-up here, find P of 15 if P of T equals 2.99 times 1.04 to the T. What does P of 15 tell you to do? Plug in 15, yeah. So it's literally saying, hey, don't use T, plug in a 15 in place of T. So 3.99 and 1.04 stays, and in place of T, we're putting in a 15 instead. And so I want you to plug that into your calculator. Plug it in, plug it in. And what do you get? Someone be brave. 7.185. We're going to go ahead and just round to the hundreds place today because most of us are talking about money. So we're going to say 7.19. And again, that is all in your calculator. Not hard to do, but if you don't have a calculator, you cannot do it. Okay? You must have a calculator. That's essentially what we're doing today. We are using models. And so I'm going to have you guys write this down. I will dictate this to you so you can write as I read. Example 1, the value of a car. The value of a car. Depreciates 15% per year. Depreciates 15% per year. Can be modeled by V equals V sub 0 times 0.85 to the T power, where V sub 0 is the initial cost of the car. Excuse me. And T is time in years. Find the value of the car. If the car cost $17,000 originally after 3 years. It's kind of weirded wordly now that I look at it again. But the important thing here is that they're giving us a model. And when you're given a model, you're going to use the model. All this extra stuff, 15% per year, is extra information. They gave you a model, so that's what we're going to use. Now, if you'll notice, 15%, how did we get 85? Is 100% minus the 15% because it's depreciating. So this is what we're paying, or what's retaining, 85%. So that's where the 85 came from. But I have V equals V naught 0.85 to the T. This is the model we're going to use, and we just need to plug in what we know. It says V naught is the initial cost of the car. That's the initial value, the starting value of the car. So what should we plug in place of V naught? Yeah, that is our 17,000. So I'm going to plug in the 17,000. times the 0.85 to the, and what are we going to put in place of t? 3 years. That's the time. T is time in years, and we want to know what's happening at the end of 3 years. So what is the value of the car after 3 years? So go ahead and plug that into your calculator. And the big thing here is, can you plug it in properly? That's all this is. I am sure you all can write the model out. The question is, can you use your calculator correctly? So please plug it in. And you should get, is our value of the car going to go up or going to go down? It's going to be less. Yeah, it's depreciating, going down. All right, so we get 10,000 what? 440.13. Again, rounding to the hundredths place because that would be money. We're talking about money, so it makes sense to round to pennies. Okay, so 13 cents. All right, so V equals, what should we put in place of V naught? What is the initial cost of the car? 25,000, and then the 0.85, and what are we going to put in place of time? 5. So again, plug that into your calculator. And after 5 years, how much is that $25,000 car worth? $11,092.63. Less than half of its value. All right, anybody have problems with their calculators? Let me know. Gotta know how to use your calculator. Okay. All right. So the other thing we're talking about today is compound interest. So write all this stuff down. Compound interest. This is the formula that we use for compounding interest. Compounding interest is, I don't know how many of you have a savings account, but when you have like a savings account, you get a statement from your bank usually every month, and they would tell you how much interest you earned that month. And it's usually on the order of 2 or 3 cents. It's a whole lot of money. And so that is bank compounding interest every month because they give you a statement every month. And so really that just means how often do we calculate the interest that you're earning. This formula gives you the amount in your bank account. So this is P times the quantity, 1 plus R over N to the NT power. And N is the number of times, the number of compoundings per year. How many times do we calculate the interest every year? Okay. And so these are all the different common ways that we could compound interest. We can compound it annually. Annually is how many times per year? 1 time per year, so N equals 1. Semi-annually is how many times per year? 2 times per year, so N equals 2. Quarterly is how many times per year? 4 times per year. Monthly would be 12 times per year. Weekly would be 52 times per year, and daily 365 times per year, roughly. Okay, these are the common conversions for that. All right, so we want to know what everything else in this equation represents. So P is the principal. That's the name of it. I can never remember how to spell it. But principal just means our starting amount. And so this is our starting amount of money, or whatever our starting population is. It doesn't matter what we're talking about. It's our starting amount, our initial quantity, whatever we start with. And then 1 plus R. What do you think R stands for? Rate. R is the rate, and that would be like the interest rate. As a decimal is really important. You're going to be given interest rates as percentages, like 6.5%. That looks like a decimal, but it's actually a percent because it's got the percent symbol there, and we never do calculations with percentages. Percent is a literal thing. It is literally per cent, as in per 100. And so if you take 6.5 and divide it by 100, 6.5 per 100 is 0.065. So that's as a decimal, 0.065. When we divide by 100, all it does is move the decimal 2 places to the left, and that's where we get the 0.065 from. And so this is your rate as a decimal. So make sure that you move the decimal 2 places, or remember that percent means divide by 100, okay? And then what do you suppose T is? Time in years, yes. Time in years, usually. And so this is the model, and again, the idea is we're just going to plug everything in. And A represents the amount after T years have passed. So this hopefully is a lot more money after 5 years have passed or after 10 years have passed. Hopefully the amount in our account is much bigger, right? Because we're adding extra stuff to it. All right. So we're going to use that model to figure out example 2. Example 2, find the amount accumulated for the following investments. Example 2, find the amount accumulated for the following investments. Find the amount accumulated for the following investments. And so it says $800 for 10 years at 7% compounded weekly. And this compounded weekly is really important because when you hear those words, compounded weekly or compounded daily or compounded monthly, then that tells you the formula you're going to use is A equals P times the quantity, 1 plus R over N to the NT. And that's definitely a formula you want to know and hopefully memorize. It's a good formula to know. And so we're investing. What is our P? What is our principal amount? It's the 800. Yeah, our starting amount. We're starting with investing $800. So we're going to put that in place of P. And then we have times the quantity 1 plus. What should we use for R? All right, so 7% is the percentage rate, but we don't want to use it in this form. So what should we do to get R? Is it 0.7 or 0.07? 0.07, yes. So you take your decimal and you move it 2 places, and that makes a big difference, okay? The difference between 0.7 and 0.07 is huge. So 0.07 over N. If we're compounding weekly, how many times per year is that? 52. So n weekly, n is 52. So we're going to divide by 52. And then to the, again, we have the same n, that's 52, times t. What's t? 10. T is 10. So this is where you can plug it directly in pretty easily. With the Casio, you want to make sure that you put your exponent in parentheses so that all of it is up in parentheses. But really, you can just type it in pretty much as it is in one nice long line. So 800 parentheses 1 plus 0.07 divided by 52. And then caret to the 52 times 10. And again, if you have a Casio, you're going to need parentheses around after you do the caret. And so hopefully you got the same thing. If you did not get $1,610.24, then you typed something in wrong. So let me know if you didn't get it. Did anyone not get it? This is really important that you know how to use your calculator. The little idiosyncrasies. Oh, that's a good word. All right. So we have $3,400 for 25 years at 6.25%. Again, compounded monthly tells me that I want to use A equals P times 1 plus R over N to the NT. That compounding interest formula. What is the 3,400? The P, yeah, 3,400 is the P. 1 plus, what should we put in place of R? Yeah, 0.0625. Again, that decimal moves 2 places, 2 bunny hops. 0.0625 over, what's N? If it's compounded monthly, that would be N equals 12 times per year. Good. So N is 12. We got another 12 up in the exponent. And then what's T? 25. So again, our job is to plug this in properly. Make sure you can use your calculator. So again, you can type it pretty much directly in. Yeah. All right, so on the Casio, 3,400 quantity, 1 plus 0.0625 divided by 12. Close my parentheses, so that's all the same. I'm going to use the caret button, so that's the little arrow up, the caret there, the caret guy. Ooh, sweet spot, where are you? There, okay. And then just here, just for that exponent, you want to make sure that you get parentheses. So parentheses 12 times 25. And I get the same thing, $16,154.85. Okay. Do you guys have any questions for me? Super easy worksheet. So when you do your worksheet today, what I hope to see is you plugging in the numbers to the formula and you giving me an answer. That's it. Super easy, super fast, okay? This is CP3rd.